Oh, let me summarize it. Okay, so like I said, we're going to, we took 4 days to take a test. So we're going to kind of play catch up a little bit here. By blending together 5-1 and 5-2, honestly, it kind of, it works. Because there's only one difference between 5-1 and 5-2, and it is an equal sign, okay? So everything you need to know for both 5-1 and 5-2 is on this slide. Obviously, I would screenshot it. I would begin to start to memorize it because it makes your life easier. But also, Corona perk, you can print that, okay? This is your reference sheet for everything we're about to do. Some of this you already know. Most of this, actually, you already know, which is the reciprocal identities at the top. Obviously, hopefully, we know that, and we know that from the top of our heads. We don't have to look at that. We should know that cosecant is the same thing as 1 over sine, secant is the same thing as 1 over cosine, and cotangent is the same as 1 over tangent. Now, what's different, what we haven't talked about, is that tangent is sine over cosine. If you think about it, opposite over hypotenuse, and then adjacent over hypotenuse, keep, change, flip, and you get sine over cosine, okay? Cotangent is cosine over sine. So what we're going to start to do is replace one with the other. When you see tangent and you see other sines and cosines, you're going to replace tangent with sine over cosine. If you see cotangent, you're going to replace it with cosine over sine. These are also new this year, but you should have heard of them last year, and they are called Pythagorean identities. The first is sine squared plus cosine squared. That's kind of like the foundation one, because the others, I'll show you a trick to get to them, which you won't need to do for now, but eventually moving forward, if we go without notes or standardized tests, you won't have them. Tangent squared plus 1 equals secant squared, and then 1 plus cotangent squared equals cosecant squared. So anytime you start to see squares, usually, is when I start to see, is it possible to replace it with a Pythagorean identity, and that's what those are. Even and odd, we talked about last chapter. Remember that cosine is even, because even if you change the sign on the angle, which is the negative x, it doesn't change the sign on the trig function. So what happens is these won't be values anymore. You will literally see something that says sine of negative x, and you know for that I have to replace it with negative sine of x. You'll see something that says cosine of negative x, and you'll know you have to replace that with cosine of positive x. And then tangent of negative x gets replaced with negative tangent of x. So the one that loses the negative is the cosine, because it's even. And then we also talked about cofunctions. Remember, these are ones that you use the complement, and sine goes with cosine, tangent goes with cotangent, secant goes with cosecant. Again, when we did them the first round, I gave you like sine of 30, and I would say what's the equivalent, and you would give me cosine of 60. Now you're literally replacing it with the symbols. You're not using numbers there. So when I see sine of 2 pi minus an angle, like this one is the u, it could also be theta or alpha, whatever, I replace it with cosine. If I see cosecant of pi over 2 minus an angle, I replace it with secant. So in all of these, we are using substitution. We are substituting something in the other place.
Use an angle then?
Yes, use just the name of an angle. Yep, same thing with x. You'll see theta. You'll see a bunch of different variables built in there.
Okay.
That's one of these.
Oh, I was going to look at the Pythagorean identity.
No, not, yeah. As soon as I see...
U is the...
Okay, so the first thing is the application of some of that stuff, and then we'll get into actually verifying. Use the given values to find the values of the 6 trig functions. So this time I tell you that sine of pi over 2 minus x is 12 over 13. And the sine, this should say sine of x, is negative 5 over 13. So this is the first thing you can replace. What is the same thing as sine pi over 2 minus x?
Cosine.
Cosine of x. Good job. So really this is telling you the cosine of an angle is 12 over 13, and the sine of that same angle is negative 5 over 13. Are these unit circle values? No, which means?
Triangle.
Triangle. Set up a right triangle. This time I'm going to put x in the corner, but the same thing as theta. Cosine being 12 over 13 adjacent over hypotenuse. Sine is negative 5 over 13. So that negative could have gone with the 5 or with the 13. Because it's opposite over hypotenuse and the hypotenuse is always positive, I know the 5 gets the negative. So now I already have sine, I already have cosine. Tangent would be opposite over adjacent. Cosecant would be the reciprocal of sine, negative 13 over 5. And secant would be the reciprocal of cosine, 13 over 12. So the right triangle trig does not go away. It's just that you're now going to use it with your properties.
Why is the sine pi over 2 minus x become cosine?
Because look, pi over 2 minus something, I go back to my cofunctions. Like that should be your trigger. This says, look at my cofunctions.
Okay.
If I saw a negative inside, I would look at my even odd functions. If you have something that's squared, I look at my Pythagorean. So those kind of are the triggers. All right, now we get into the first part of verifying trig identities. We are taking something that is an expression that is complicated, or not complicated, but more complicated than we want it to be, and we need to simplify it. The goal would be to get it in terms of sine and cosine. If we can get it down to one term, even better, okay? So cosine times secant x minus cosine x. What's your gut tell you to do with this expression?
Distribute.
Distribute. So let's distribute cosine of x times secant of x minus cosine of x times cosine of x. Now the cosines, I'm usually going to leave alone. The sines and the cosines you're usually going to leave alone. But your reciprocal functions can get replaced. So what is the same thing as secant of x?
1 over cosine.
1 over cosine of x. Good. Minus, now this is when it's weird, is how we multiply these out. Cosine of x times cosine of x is actually cosine squared of x. We don't change the angle, we just multiply the trig function. So now what happens with cosine of x times 1 over cosine of x? Cancel out. And I just get 1 minus cosine squared of x. Can I simplify that? As soon as you see the ones and the squareds, go back to your Pythagorean identities, right? So there's a Pythagorean identity that says sine squared x plus cosine squared x equals 1. It's not the same, but if I were to move the cosine on the sine with the 1, now this matches that, so this whole thing gets replaced with sine squared of x. The hardest part about simplifying is knowing when you're done. That's where the verifying comes into play. If it said equals sine squared of x from the beginning, you would know you're done. You want to get the left side to equal the right side. The hardest part of simplifying is knowing when you're done. If you can get it to one term, you're good. If it's a reciprocal function like 1 over sine squared, then I would make it cosecant squared. So just keep that in mind. You're not always going to get it to be one term. Is that you already? No, right?
No, we have 9:20.
Oh, mini panic attack. That would have been a lot of a video. All right, questions on that one? All right, this one actually says factor the trig expression. So we go back to factoring, okay? You can leave it as it is and say 3 sine squared x minus 5 sine x minus 2. I set up my 2 parentheses. Break this apart, so it'd be 3 sine of x and sine of x. And then the factors of negative 2, plug those in until I get the middle term. So I could do a positive 1, negative 2, multiply the outer 2, that's negative 6 sine x, multiply the inner 2 plus 1 sine x, and I get negative 5 sine x, which is the middle term. So I know I factored this correctly. If the signs throw you off, the SIN signs, then use substitution. So take whatever that middle term is and say like A equals sine of x. And then rewrite it without the sign. So it'd be 3a squared minus 5a minus 2. And then you can factor that a little bit simpler. So do the same thing, 3a and a. I would have tried and did the trial and error on the other ones, and I would have gotten this. Just remember at the end to take that sign and plug it back in to the a. So it's 3 sine of x plus 1 sine of x minus 2. Either way, you end up with the same answer, but how you choose to do that's up to you. You can either do the substitution or you can keep working with the sign. Questions on that one? So sometimes they literally tell you what to do like that, like factor, and sometimes they don't. Sometimes they just say simplify. And really this leads more into solving. When we get to like 3, 3, we're going to solve this then. We'll set them equal to 0 and solve. Right, you're just simplifying. All right, example 4, perform the multiplication and use the fundamental identities to simplify. So again, it's telling you what to do. I'm going to multiply this out. So I'm going to not distribute the squared because that's wrong. I'm going to expand and FOIL. So sine of x plus cosine of x. Sine times sine is sine squared x. Sine times cosine, sine x, cosine x. Cosine x, sine of x. And cosine times cosine, which is cosine squared of x. With me so far? All right, what can I do with that? Is sine of x times cosine of x the same as cosine of x sine of x? Is that the same term? If it was a, b, and b, a, would those be the same terms? Could you combine them?
Yes.
Yes, you sound very sure of yourselves today. Good job. Okay? Yes, it's multiplication, so order doesn't matter, right? If it was sine plus cosine and or sine minus cosine and cosine minus sine, that's different. But if it's multiplication, order doesn't matter. So I can actually combine these into one. Sine squared of x plus 2 sine x cosine x, and the order there doesn't matter, plus cosine squared x. Now is that as simplified as I can get it? No, what can I do there?
You have to type the identity.
Good. As soon as I see squared, right, I check my Pythagorean identities. Is there a Pythagorean identity I can do to combine sine squared x with cosine squared? Yeah. Yes, the answer is yes, sorry. So that gets replaced with 1. And then 2 times sine x cosine x. There's nothing I can do there. If they are sine and cosine, I'm done. If it was like sine and tangent, I would try to replace tangent as sine over cosine. If it was cosine and tangent, I could actually simplify it. But if it's just sine and cosine, you're done. All right, just some more examples. So use the fundamental identities to simplify the expression. Sometimes they are very basic, just multiplication. What can I replace cotangent with?
One over tan x.
Okay, 1 over tan. What can I replace secant with? 1 over cosine. So the tan didn't really help me there, right? But what else could I replace cotangent with?
Cosine over sine.
Cosine over sine. And now the cosines cancel. I get 1 over sine of theta. Is that as simplified as it gets? What is it? Good. 1 over sine of theta is cosecant. Again, remember, if you can get it to one term, that's as simplified as you can get it. You want to keep going. Questions on that one? All right, B. 1 minus sine squared x, and then cosecant squared x minus 1. So again, train yourself. As soon as you see squareds, especially not just by themselves, but a squared with a 1 or with another term, look at your Pythagorean identities. So sine squared x plus cosine squared x equals 1. And then what are my other ones? Here, I'll tell you how you can find them, right? So let's pretend we don't have that answer sheet. We arrived to school with no notes. Or, at some point, the world will expect you to just use your brain. And for those times, you'd need to know this. If you take this initial function, if you know this one, and you divide it all by sine squared, sine squared over sine squared is 1. Cosine squared over sine squared is cotangent squared. And 1 over sine squared is cosecant squared. There's the second one. If you start with the first one again, and this time divide everything by cosine squared. Sine squared over cosine squared is tangent squared. Cosine over cosine, 1. 1 over cosine secant squared. And there's the last one. So those are the 3 Pythagorean identities. Again, obviously you'll get to use your reference sheet for this test. But moving forward, or just simply because you want to learn those, because they're not going to go away, that's how you could find the other 2. All right, so now I know that this one matches with this. So if I have sine squared plus cosine squared, and I want equals 1, and I want to get it to 1 minus sine squared, that means I move the sine over to the other side. And this whole thing is cosine squared. Then the bottom one, cosecant minus 1, I look at that second one. So if I want to get 1 plus cotangent squared equals cosecant squared, to where it's cosecant minus 1, I'm going to subtract the 1. And I get cotangent squared equals that. So that gets put over cotangent squared. This is not the only way to do it, by the way, but this is one of the ways to do it. I think it's simplest.
For these here, you can't simplify cotangent squared to like being cosine squared over sine squared.
Yes, you can actually, Matt. You can, yeah. Because that's not done. So this would be cosine squared x over sine squared x. And then I want to keep change flip. So it's gone from here. The cosines cancel, and all I have left is sine squared x.
So this question is, or how do you know if you want to end with sine 2 or with the
This,
minus 1?
if there's a reciprocal, oh wait, with the minus 1. Oh, with 1 minus cosine, you mean? One term is simpler than 2, always. So Maria just had a really good question. How do I know I want that and not 1 minus cosine squared x? The answer is one term is always simpler than 2. So if you get to this point, you know you need to go to the next step. Good question. It's not wrong. It's just not as simplified as it could be. Yeah, that's where these get tricky. Questions? Sure. Okay, last one, and then we're switching. So rewrite the expression so it's not in fractional form. It legit tells you somehow get rid of that fraction. So when you write your answer, there should be no fraction. So I have sine squared y in the top and 1 minus cosine y. And this is one of the most common mistakes people make, is replacing this with sine of y. Those Pythagorean identities have to be squared. You cannot use it with just cosine. So you cannot do that. There's nothing else we can replace 1 minus cosine with, which means we're going to do what? Replace the sine squared. So how do I replace sine squared so that's going to help me with that denominator? Sine squared plus cosine squared equals 1. What would sine squared equal?
1 minus cosine squared.
Good. So I do 1 minus cosine squared y over 1 minus cosine y. Can I just like cross through the 1 and the cosine and leave a cosine?
I wish.
No. What do you have to do with that top?
Factor it out.
Good. This is the difference of two squares. So it's 1 plus cosine of y, 1 minus cosine of y, over 1 minus cosine of y. The 1 minus cosines cancel, and I get 1 plus cosine of y. The goal was to get rid of the fraction, we did. And I cannot combine those into 1, so it's going to stay just like that. Except, I think easier because you have an ending. So this says verifying trig identities. This slide is still the exact same as the first slide for 5.1 because it's still the only thing you need to know. Everything you need to know comes from that.
That you're excited?
Yeah. Oh, you did. Make sure I didn't hit submit. Okay, so here's some strategies for moving forward. Okay, these don't always work, and it's hard because they're different at different times. But this is just some suggestions. So the first thing is that it's going to be an equation. It's going to be this equals this. Usually you can just work with one side to get it to equal the other side. And you usually work with the more complicated side. So that's what this says. Usually pick that more complicated side, try to simplify it to get it to look like the other side. In not all cases are you going to be able to only work one side. It's okay to work both sides. But the goal is to get the left side to equal the right at the end. Okay? The third thing there says try using one or more of the following techniques. Rewrite the more complicated terms in terms of sine and cosine, which we've been doing. Factor out greatest common factor. So sometimes you have to look for that. When there's a fraction at the beginning in which you have two things added or subtracted together, sometimes you've got to split them. And then sometimes you go the other way. You've got two fractions and you have to combine them into one. And then sometimes you can multiply both the numerator and the denominator by a factor that appears on the other side of the equal sign. So you can move things around. Here's the biggest thing, is if you get to a dead end, don't freak out. Sometimes you literally have to stop and start over again. Does it suck? Yes. But is it something that we have to do sometimes? Also yes. Okay? So now I have an end, which again I think is easier. It's always easier when you know what your goal is, right? So now I'm going to look at the left and I want to set it equal to the right. I want to eventually get it so that the left equals the right. Which of these sides is more complicated?
The left.
The left. So I'm going to look at that first. What do I see on the left-hand side that I can replace?
You can make the cotangent cosine over sine f.
Okay. Anything else you see that you could replace?
The left to the cosine plus.
Sine squared plus cosine squared is 1.
The cosecant can be switched.
The cosecant can be switched.
To,
Okay.
1 sine over f.
Why am I not surprised you're making this more complicated than you need it to be? It seems about right. So be what? Say that again. 1 over
1 over
sine
squared
squared of x.
And then you divide it, so then it flips, and then you cross, and it's 1 over cos 2.
Divide what?
The cosine 2x over sine 2x.
What do you mean divide it?
Like divide it with the, like move it to the other side.
Move this to the other side.
Yes.
All right. All right. 1
Oh, you're subtracting. Never mind.
minus. Okay, but yeah, because it still works. Now what? Yeah, I'll do that next. Now what? No. Keep going. Keep going. Now you have the same denominator, yes?
Mm-hmm.
What's 1 minus cosine squared of x?
Yeah. And then,
Sine squared,
Sine squared.
and then it equals 1.
Uh-huh. Did that work? Absolutely. Is there a different way? Yeah.
So just change the cosine square x plus sine square x to 1. And then change the cotangent square x to cosecant square x minus 1.
Oh, you don't even need to do it.
Oh.
Yeah, because what's your trig identity with cotangent?
Cosecant square x minus 1.
Oh, okay, I see what you're saying. So you're replacing that with, hang on,
I'm replacing the cotangent.
yep. Just this you're replacing.
Mm-hmm.
Cosecant squared x minus 1 plus 1.
And they cancel out.
You caught from here, right? Here. You said multiply everything by sine squared? Is that what you're saying to do? So from there, you could have also done everything. So it cancels from here. Cosine squared x. Sine times that would be sine squared x. Times here equals 1. So look, just in this one example, 3 completely different ways to do it. All of them are right. Maria chose one that was very complicated. I'm not surprised. Okay? But know that there's more than one way to do these. Okay? And you have to figure out, like, if you get to a dead end, start it over, because sometimes you catch something different the next time around. And this is my biggest thing, is don't give up on homework and don't give up on these kinds of questions, because the last one actually might be the easiest one for you. They're not always in increasing difficulty. You might see something that just clicks. Okay? So one of the things I would say is, like, obviously look at something like this. They look like they're very similar, but they are not. Like, I can't just cross through one part or the other. When I'm talking about complicated, obviously the subtraction is more complicated than the multiplication, okay? So if you see something like a tangent and a sine, I can replace the one on the right with sine over cosine, squares and squares, but it's not going to cancel anything out. So if it was like cotangent and sine, then it's going to simplify the right-hand side, which means I'm probably going to have to work with the left. I cannot combine these together by themselves. There is no Pythagorean identity that has tangent and sine, which means try to get this in fraction form and combine it into 1. So tangent becomes sine squared over cosine squared minus sine squared of x equals tan squared of x sine squared of x. Now if I want to get this into 1, I have to give it a like denominator. So what do I have to multiply sine by? Sine squared.
Cosine squared.
Good. So I'd get sine squared x over cosine squared x minus sine squared x times cosine squared x over cosine squared x. Now they have the same denominator. Sine squared x minus sine squared x cosine squared x over cosine squared x. Now remember I said look for GCFs? This is why. I can actually factor out that sine squared x. And I get 1 minus cosine squared x. What's 1 minus cosine squared x? Pythagorean identity is sine squared plus cosine squared equals 1, right? So 1 minus cosine is sine. Now I'm getting closer because there's a sine squared x. And I can actually work the other side to get it to this point, because I could have made tangent sine squared over cosine squared and got it to this point. Or what you can do with a fraction that is all multiplication in the numerator is break this apart. So I can actually break off and make it sine squared over cosine squared times sine squared. And then sine squared and cosine squared becomes tangent squared. Again, I could have worked from the beginning to the right-hand side a little bit, tweaked it. You could have gotten sine to the 4th over cosine squared, so that when I got to this point, I could have made that sine to the 4th over cosine squared. You can work both sides. Remember that the goal at the end is to just get the left side to equal the right side. How you get there could change. Let me just show you one quick trick, a lot easier, on these. And then your homework, I'm going to blend like 5-1 and 5-2 together. So I got to add on a little bit of 5-2. When you're dealing with fractions that have reciprocal functions, not even reciprocal functions, any kind of function, you can actually move a function from the top to the bottom by making its reciprocal. So it's a shortcut because normally I'd have to divide and then keep, change, flip and go through that whole process. But I can actually just move this to the top by making it sine. And then that becomes sine squared of x. Move this to the top by making it cosine. And that becomes cosine squared of x. And I get 1 equals sine of x times cosecant. And sine of x can stay. Cosecant become 1 over sine. And I get 1 equals 1. So this happens, like you can move a function from the bottom to the top only if it's by itself. Like I couldn't do that if it was cosecant plus 1, okay? But you can move it by making it its reciprocal function. All right, I will finish. All right, cotangent times 1 plus tangent squared x over tan x. What do we see here we can simplify? 1 plus tangent squared is what? Secant squared. Now what?
You can move tan to the top.
I can move tan to the top, so I can make it cotangent squared times secant squared. Then what? The faster you finish, the faster you get to go. What's cotangent? Cosine over sine. Ooh.
And then
What's secant?
1 over
1 over
cosine.
cosine.
And that cancels into 1 over sine. 1 over sine is equal to cosecant.
See how easy it is?
Puzzle.
It is like a puzzle. Whoops daisy. Remember, you can move it to the top or you can make it its reciprocal function. All right, there's one more example. I'll finish it on the video, but remember your homework, which I have not published yet, will be both 5.1 and 5.2 put together. I want to streamline it a little bit. I want to shorten it, okay? And that's due Monday. And then we'll move to 5.3, review, quiz, one more section, test. Oh, yeah. Have a fantastic day, guys. All right, in this one, it says verifying the identity, sine of x over sine x plus cosine of x equals tangent over 1 plus tangent. So if this was in the numerator, you can actually split it up so that if it said like sine of x plus cosine of x over sine, you could actually split that into 2. Sine of x over sine of x, cosine of x over sine of x. But because it's in the denominator, we can't do that. Okay, so because it's not that way, we obviously can't split this apart. And sine and cosine can't turn into reciprocal functions, so I'm going to choose to work the right side. So I'm going to do sine x over cosine x over 1 plus sine of x over cosine x. So then I want to combine this into 1 in the denominator. I'm going to make that cosine x over cosine x. And I get cosine of x over plus sine of x over cosine of x. So that replaces this whole thing. Then I'm going to take that numerator and I'm going to do keep, change, flip with the cosine x over cosine x plus sine x. These cancel. And I end up with sine of x over cosine x plus sine x, which is the same thing as the left-hand side. So I know I'm done.